All right, today we're going to dig in. And I mean that literally. We're getting into the very foundation of India's geography, its agriculture, and even its culture. We're talking about soil. And trust me, this isn't just about dirt. This is about destiny. So let's get started.
You know, the ground beneath our feet, it isn't just a passive thing. It is a living, breathing narrative. It's a geological story that dictates what grows where, what a nation eats, and how entire civilizations have developed. So the big question is, what story is India's ground telling us?
Our journey kicks off in the north, in those vast, life-giving plains that make up India's incredible agricultural heartland. This is ground zero for India's food security.
And the main character in this part of the story? It's alluvial soil. You'll find it all across the Indo-Gangetic Plains and the Brahmaputra Valley. You can think of this as the soil of the rivers. It's built up from all the fine silt that these massive river systems have deposited over thousands and thousands of years. That makes it ridiculously fertile. It is the absolute bedrock of Indian agriculture, and it's really no surprise that this region is one of the most densely populated places on the entire planet.
But you know, not all alluvial soil is created equal. You've got two main types you need to know: Khadar and Bangar. Khadar, that's the new stuff. You find it right in the floodplains. It's made of fine particles and gets a fresh top-up every year from the floods, making it super fertile. Bangar, on the other hand, is the older soil. It's found further away from the rivers, so it's a bit coarser and not quite as fertile. So the key takeaway here? When it comes to alluvial soil, being close to the river is everything.
Now, if we look at what it's made of, chemically speaking, alluvial soil is a real powerhouse. It's just packed with potash, lime, and phosphoric acid, basically all the good stuff you need for those big staple crops. Now, it is a little low on nitrogen and organic matter, but its overall richness is exactly why this region can grow enormous amounts of rice, wheat, and sugarcane. It's a perfect example of the direct line between soil chemistry and what ends up on our dinner plates.
Okay, let's journey south now, down to the Deccan Plateau. Here, the soil story just explodes into a vibrant tapestry. We've got a whole new cast of colorful characters, and each one has its own unique personality.
First up, we've got black soil, which you might also hear called Rigur. I love its nickname, the Great Sponge. Why? Because it's extremely clayey, which gives it this incredible ability to hold on to moisture. Then, when it dries, it develops these deep cracks, which kind of aerates the soil naturally. It's so effective that people often call it self-plowing.
You find this soil all over the Deccan Traps, which are these ancient volcanic rock formations, in states like Maharashtra and Gujarat. It's rich in things like lime and iron, but it is lacking in nitrogen and phosphorus. But that superpower, its ability to retain moisture, makes it the absolute perfect home for a really thirsty crop: cotton. And that is exactly why this region is the heart and soul of India's cotton industry.
Okay, sticking with our colorful theme, the next soil is maybe the most visually striking, but it begs a really simple question, right? What makes red soil, well, red?
And the answer is actually pretty simple. It's rust, that's it. A high concentration of iron oxide gives the soil that distinctive reddish color. It's a fantastic case of simple chemistry, creating geography's color palette.
This soil covers huge parts of the southern and eastern Deccan, and while it's rich in iron and potash, it's pretty poor in almost everything else you'd want: nitrogen, phosphorus, lime, organic matter, you name it. What this means is that for crops like millets and pulses to really thrive here, the soil needs a little help, usually in the form of fertilizers.
All right, I've got another question for you. What do you think happens to soil in a place that just gets absolutely hammered with heavy rainfall, year after year after year? Well, it creates something totally new.
The process is called reaching. The best way to think about it is like making coffee. You pour hot water over the coffee grounds, right? And the water washes all the good stuff, the flavor, the caffeine, down into your cup, leaving the used grounds behind. In nature, intense rain does the exact same thing. It washes away the soluble minerals and nutrients from the topsoil, leaving a completely different kind of soil behind.
And that leftover soil is laterite soil. You find it in the super high rainfall zones like the Western and Eastern Ghats. It's a direct result of all that leaching. So it's rich in what's left behind, iron oxide and aluminum, but it's been stripped of most of the key nutrients. This makes it pretty bad for traditional food crops, but it turns out it's perfect for hardy plantation crops like tea, coffee, and cashews, which is specifically adapted to these tough conditions.
Okay, for the final leg of our tour, we are going to the extremes. From the sun-baked deserts out west to the towering, forested mountains up north. As you can imagine, these places have highly specialized soils forged in some really challenging environments.
Over in Rajasthan and parts of Gujarat, you run into arid and desert soil. And it's pretty much what it sounds like. It's sandy, it's salty, and it has a really hard time holding on to any moisture. Agriculture here is a serious challenge, although modern irrigation has made it possible to grow some tough crops, like bajra.
Now, in complete contrast, you go up to the Himalayas and you find mountain and forest soil. The most fascinating thing here is just how much it changes. The soil's composition can vary dramatically with altitude. Way up high, it might be super rich in organic matter from all the decaying forest life, but just a few hundred meters down the slope, it can be something completely different.
And finally, let's talk about peaty and marshy soils. You find these in really waterlogged coastal areas, like the Sundarbans or in Kerala. This soil is acidic and just loaded with heavy organic matter because it's been sitting in water without much oxygen. On its own, it's not immediately useful, but if you can drain the excess water, it becomes an excellent place for paddy or rice cultivation.
Okay, we have covered a lot of ground, literally and figuratively. So let's bring this all home with a high-yield summary. This is the core information you're really going to want to lock in.
This table right here, this is your ultimate cheat sheet. It lays out what key minerals are present and, just as importantly, what minerals are deficient in each major soil type. You can start to see the patterns, right? Alluvial is rich in potash but needs nitrogen. Black soil has iron but is missing phosphorus. Red soil's got iron but is low on lime. This is a fantastic slide to just pause on and really let the key details sink in.
And if you just need one sentence to rule them all, this is it. This is a high-yield line that's often used to remember the most critical deficiencies for each one. Let's just say it out loud. Red soil lacks lime, laterite lacks fertility, black soil lacks nitrogen, and alluvial soil lacks organic matter. That's a master key for your memory right there.
So let's end with a final thought. We've seen exactly how soil chemistry decides whether a farmer is going to plant wheat or cotton, tea or millet. But if the soil dictates the food on our table and the entire economy of a region, how far does that influence actually go? How does the very ground beneath our feet shape a nation's destiny? It's something to think about. Thanks so much for joining this explainer.